Let's take a look at problem number 7 using a tree diagram. In this problem we have two boxes with marbles in them. Box A has 2 green and 5 blue marbles for a total of 7. And box B has 9 green and 6 blue for a total of 15. In this problem, we're going to be taking a marble from box A and transferring that marble to box B. After that, we'll draw a marble from box B. Now, since we're transferring a marble to box B each time, ultimately box B is going to end up with 16 marbles. The color combinations are going to depend, though, on what we pick from box A. We're trying to find the probability that a blue marble was drawn from box A if we know a green marble was drawn from box B. Another way to say that would be the probability of blue from A given green from B. Now remember, in a given situation, the second quantity is actually the event that is supposed to happen first. In this scenario, though, I'm always picking one from A and transferring it to B. So how can I know what's the probability of the reverse event happening? Well, that's where Bayes' theorem comes in. And so, in order to figure out the parts of the fraction for Bayes' theorem, I'm going to construct a tree. My tree is going to have two basic events. The first event is going to be drawing the marble from box A. And that event can have two outcomes. It can either be a green marble or a blue marble. After I draw the marble from box A and transfer it over to box B, the box B drawing is the second event, which can also have two possible outcomes. I can either get a green or a blue, and that's going to be the same possibilities from box B, whether I drew a green or a blue from box A to begin with. Now let's go back and add our probabilities here. So starting with box A, the probability of getting a green from box A would be 2 out of 7, since there are 2 greens out of 7 total. The probability of getting a blue from box A is 5 out of 7. Notice that these two add up to 1 because they are the two events that complete that entire sample. Now I want to look at the box B possibilities, and I'm going to start with what happens if we draw a green marble first out of box A. Well, if I draw a green marble out of box A and transfer it to box B, then I'm no longer going to have 9 greens, I'm actually going to have 10 greens. And so with 10 greens out of the new total of 16, the probability of getting another green is going to be 10 out of 16, which reduces to 5/8. If I draw a green out of box A and then transfer it to box B, the probability of getting a blue next is going to be 6 out of 16, which is 3/8. Notice again that these two fractions right here add up to 1. Now let's go back to box A, and this time I want to draw a blue marble out of box A and find the probabilities of each of these other second events from box B. Since I'm drawing a blue marble from box A, I'll be transferring it to box B. So instead of 9 greens changing to 10 greens, I'm going to have 6 blues that change to 7 blues. And so the probability of transferring that blue marble and then getting a green marble is going to be 9 out of 16. That fraction can't reduce, so I'll just leave it as 9/16. The probability of getting the blue marble first, which we transferred, and then getting a blue marble again will be 7 out of 16. And again, these two add up to 1. Now that we've got the tree complete, we're ready to construct our probability. So remember, the top part of the fraction is the way to achieve what we want to happen. We want to have a blue out of A, green out of B. And so that would be this part of the tree right here. So I would have 5/7 times 9/16 on the top of the fraction. On the bottom of the fraction, I want to have everything that creates this sample space right there. So I want to have everything that's going to give us a green out of B. Well, one of those options is the one that I just found and used on the top, 5/7 times 9/16. The other option would be if I chose a green out of A and a green out of B. So that would be 2/7 times 5/8. And we're going to add those two fractions together. From there you can do the calculations in your calculator, and you find that the final answer for this is 9 out of 13. The probability that a blue marble was drawn from box A, if we know a green marble was drawn from box B, is 9 out of 13.